Hello and welcome. My name is Cindy Heitzman, Executive Director of the California Preservation Foundation. Thank you for joining this webinar titled Striking a Balance, Fire Protection in Historic Buildings. The format for today's webinar will include an hour presentation followed by time for questions and answers. There's a toolbar on the right side of your screen. If you have a question at any time during the presentation, please type it in the box and I will either reply to you or hold the question until the end for the panelists to answer. Please refer to the Audio tab in the toolbar and select if you are listening through your telephone or speakers. To hide or unhide this toolbar, click on the orange arrow and please adjust your volume on your computer or phone. Today's presentation will be by Cheryl Domnich and Kurt Schindler. Cheryl Domnich is a senior engineer with Hughes Associates, Incorporated. She has over 28 years of experience in California in the fire protection engineering profession and is a registered professional engineer in fire protection in the state of California. Cheryl has a wide range of consulting and design experience in historic buildings, sites, and protection of cultural resources, including ample experience utilizing the California Historical Building Code. In addition to being active with the California Preservation Foundation, she also serves on the National Fire Protection Association's Cultural Resources Technical Committee. Kurt Schindler is a principal at ELS Architecture and Urban Design and directs the firm's historic and seismic renovation projects. Over his professional career, he has been involved in master planning, programming, design, and feasibility studies for dozens of historic cultural facilities. His award-winning historic renovation projects include the renovation and restoration of the National Landmark 1903-1933 Mission Inn in Riverside, California, the 1939 Martin Luther King Jr. Civic Center in Berkeley, California, the 1929 Arlene Schnitzer Concert Hall at the Portland Center for Performing Arts, the 1923 Union Pacific Railroad Station in Anaheim, California, the 1912 16th Street Train Station Reuse Plan in Oakland, California, 1904 Temple Shereth Israel Seismic Upgrade in San Francisco, 1923 Grand Theater Center for Arts in Tracy, 1928 Oakland Fox Theater, the 1927 California Theater Renovation and Expansion in San Jose, the 1929 Pleasanton Firehouse Art Center in Pleasanton, and the 1894 St. Mark's Lutheran Church in San Francisco. He recently completed renovation of the 1915 Old Administration Building at Fresno City College and the 1934 Civic Auditorium in San Jose. Mr. Schindler holds a Bachelor of Architecture degree and a Master of Architecture degree from the University of California in Berkeley. He is active with the California Preservation Foundation and the United States Institute of Theater Technology and has presented at the League of California Cities. Thank you for joining us.
Hi, everybody. In case it's not obvious, this is Cheryl speaking and not Kurt. The way the webinar will be formatted is initially I will provide some information about various types of fire protection systems and their application in how we apply them in historic structures. After we go through this portion of the presentation, Kurt and I will both be presenting several case studies where we have applied fire protection systems within historic buildings. When we talk about historic buildings, they're generally considered to be in a special class based on society's emotional attachment to them. That's when we talk about preserving historic fabric and the defining features and the character of the building. From a fire protection perspective, I like to look at fire protection from a holistic approach, and so I've created this pie that you see on the screen that talks about the various aspects of fire protection. We have suppression, fire detection and alarm, means of egress, special considerations which can be smoke control systems, can be alternate means and methods that take other things into consideration as well, and fire-resistive construction. For today, we're generally going to focus on suppression systems as a fire protection system and fire detection and alarm systems. Later on, I think in April, there will be a webinar through the California Preservation Foundation for means of egress. So today, we'll focus here. But you'll see that when we go through the case studies, we can't only look at these two elements. We will be bringing other aspects of the pie into the discussion. When we look at historic buildings or protecting cultural resources, we cannot generally just look at the California Building Code and say, okay, we're going to walk into this building, we're going to renovate it, or we're going to make it comply with the California building. That's generally speaking impractical, and it is also at risk for damaging the historic fabric and character of the building. And so what we do when we take this holistic approach is we try to define what the goals and objectives are for the project and for life safety. And it can vary from building to building. It can vary from building to building, and what I've done is I've listed several of the elements that we're looking at. Life safety, which one might think should be number one on all the lists, but sometimes we have unoccupied buildings that are historic landmarks. I can think of several utility sites that are normally unoccupied but are characterized as National Historic Landmarks.
Cheryl?
Yes?
Sorry, we missed a button, so we need to actually start again. Sorry about that. I'm going to go ahead and go to the very beginning of the presentation. You've been muted, so they haven't been able to hear you.
My attendees, I offer my apologies. We had a little technical difficulty on this end, so we're going to begin the webinar. Hello and welcome. My name is Cindy Heitzman, Executive Director of the California Preservation Foundation, and we thank you for joining this webinar on striking a balance, fire protection in historic buildings. The format for today's webinar will include an hour presentation followed by time for questions and answers. There is a toolbar on the right side of your screen. If you have any questions at any time during the presentation, please type it in the box and I will either reply to you or hold the question until the end for the panelists to answer. Please refer to the audio tab in the toolbar and select if you are listening through your telephone or speakers. To hide or unhide this toolbar, click on the orange arrow and please adjust your volume on your computer or phone. Today's presentation will be by Cheryl Domnich and Kurt Schindler. Cheryl Domnich is a senior engineer with Hughes Associates. She has over 28 years experience in California in the fire protection engineering profession and is a registered professional engineer in the fire protection in the state of California. Cheryl has a wide range of consulting and design experience in historic buildings, sites, and protection of cultural resources, including ample experience utilizing the California Historical Building Code. In addition to being active with the California Preservation Foundation, she also serves on the National Fire Protection Association's Cultural Resources Technical Committee. Kurt Schindler is a principal at ELS Architecture and Urban Design and directs the firm's historic and seismic renovation projects. Over his professional career, he has been involved in master planning, programming, design, and feasibility studies for dozens of historic and cultural facilities. His award-winning historic renovation projects include the renovation and restoration of the Mission Inn in Riverside, the Martin Luther King Jr. Civic Center in Berkeley, California, the 1929 Arlene Schnitzer Concert Hall at the Portland Center for Performing Arts, the 1923 Union Pacific Railroad Station in Anaheim, California, the 1912 16th Street Train Station Reuse Plan in Oakland, California, the 1904 Temple Sheriff Israel Seismic Upgrade in San Francisco, the 1923 Grand Theater Center for the Arts in Tracy, California, the 1928 Oakland Fox Theater, the 1927 California Theater Renovation Expansion in San Jose, 1929 Pleasanton Firehouse Art Center in Pleasanton, and the 1894 St. Mark's Lutheran Church in San Francisco. He recently completed renovation of the 1915 Old Administration Building at Fresno City College and the 1934 Civic Auditorium in San Jose. Mr. Schindler holds a Bachelor of Architecture degree and a Master of Architecture degree from the University of California at Berkeley. He is active with the California Preservation Foundation and the United States Institute of Theater Technology and has presented at the League of California Cities, and we thank both of you for joining us today.
Thank you, Cindy.
Thank you, Cindy.
Hi, everybody. This is Cheryl, not Kurt, in case you cannot tell. Thought I'd make that clear. Welcome to our webinar today, where we are striking a balance, fire protection in historic buildings. When we think about historic buildings, they're generally in a class to be considered in a special class based on society's emotional attachment to them. For example, this photo right here is the front of the California Theater in San Jose, which Kurt and I will also be describing later as one of our case studies. And when we talk about protecting them for fire protection systems, we're talking about providing adequate fire protection and life safety, but at the same time preserving the historic fabric and the character-defining features of the building. For me, when I talk about fire protection, I have to look at the big picture. So to say that I'm only going to be speaking and describing fire protection systems is only a piece of the puzzle, which is why you see this diagram in front of you, where I've created what I call a pie of fire protection and life safety. It has several elements: suppression, fire detection and alarm, means of egress, special considerations such as smoke control systems, fire-resistive construction. For the purposes of today's webinar, we are going to focus on these systems: suppression systems, fire detection and alarm systems. And later, sometime in April, the California Preservation Foundation is also hosting a webinar on the means of egress. But we'll focus today on these systems. For an historic building, or when you are protecting cultural resources, if you are about to embark on a renovation project for them, it's oftentimes impractical or infeasible to comply with the prevailing California building code. In doing so, you may end up disturbing the character-defining features of the building, and that would be an unacceptable approach to take. So when we look at protecting the building, the first step that we need to take is to sit back and take a look at the goals and objectives that we're trying to accomplish and determine how we can provide a reasonable level of life safety while at the same time maintaining the character-defining features within the building. The California Historical Building Code gives us tools to do that, and we also use our, as fire protection engineers, knowledge and experience working with the design team to come up with an approach that's acceptable. Some of the things that we think about are life safety. When we talk about life safety, one might think that that's always at the top of the list, but I've been involved in several historic landmark projects for utilities where the buildings are unoccupied, the sites are unoccupied, but there are character-defining features about these facilities. Fabric preservation, contents when we're talking about facilities like the Library of Congress, and we're talking about historic books and documents, or the National Gallery of Art, and we are talking about art preservation, property protection, continuity of operations, and protection of building heritage. How do we define, I'm going to first talk about fire detection systems, and then I will follow it with a discussion of fire suppression systems. And when we talk about detection, we can make various choices of what we should install in our historic buildings. Are there any particular hazards that we're trying to protect from? do we need to accomplish early warning with smoke detection or even faster detection? What is the historic value of the space protected? What do we have to be aware of cultural preservation of the contents? And then we also have to think about that pie again. How is it going to interact with any automatic sprinkler system or any other suppression system that might be present in the building? For heat detectors, we have two general types of heat detectors. A spot type heat detector, just like this, it's typical. They look very similar to smoke detectors. It's just a dot on the wall, on the ceiling, and instead of there being a smoke detecting element, there is a heat detecting element. This particular heat detecting element is usually a rate compensation type. The rate compensation type is measuring the air temperature in relation to what it's been measuring in terms of the ambient air temperature. And we also have fixed temperature types of heat detectors, which just, when it gets to a certain temperature, say 165 degrees, that would trigger an alarm. An alarm would be triggered on a rate of rise detector if the temperature rises too quickly in a short amount of time. So there are different technologies associated with heat detectors. And then a line type detector is this type of detector here. It's nothing more than a wire or a cable, and when it gets hot enough, it will impact the this cable. It will break it. You will have a tear or a melt, or something else will occur that it will essentially break the circuit on that line type heat detector. For smoke detectors, we also have several different types. What you see in this photograph here are two different detectors. This was the original. This is a sleeping room. This is actually in a project that is in a historic district in Yosemite, and this is an employee housing sleeping room. And within this room, there were originally there were originally battery-operated smoke detectors installed within the rooms, and then at a later date, the facility came back in and installed wired smoke detectors, 120 volt. I'm sorry, I take that back. This is interconnected with a fire alarm system, so it's a low voltage smoke detector, and you can see in this particular application you have exposed conduit that's running back out to the fire alarm system. This particular sleeping room is a room for the hearing impaired, because you can see that we've added also a strobe device or a visual notification appliance directly within the sleeping room to accommodate a hearing, did I say visually impaired? I'm sorry, I meant hearing impaired, to accommodate a hearing impaired individual that may be present within this room. Another type of detection that has good application in an historic building would be what's called a projected beam smoke detector. In this previous application of spot type detectors, we typically space them at 30 feet on center, and so you would need to have a smoke detector installed every 900 square feet. Depends on the geometry and the configuration of the space, but you'd need quite a few of these detectors to protect a large room. One of the benefits of going with a projected beam detector is that you can protect quite a large space with just a single projected beam detector. So in this photo right here, what you see here is half of the beam detector essentially. There are two pieces that look just like this one. One is a transmitter and one is a receiver. And I can't tell you from looking at this one which side it is. I can only tell you that there's one. They look the same. One transmits and one receives. And the way they work is like this. Here is your transmitter. It transmits the light across to its receiver, and the receiver observes it. When it becomes blocked by particles of combustion, it will then sound an alarm. And Kurt and I have a case study example that we'll show you later in the presentation of a projected beam detector in an historic application. So you can protect large spaces with minimal visual impact in your environment. Another type of smoke detector, which is, I think, a very appropriate application in protection of historic buildings, would be an aspirating type smoke detector or air sampling. If we were to talk about Kleenex or tissues, when I use this term, aspirating type smoke detector, I'm talking about the tissue. The name that a lot of people associate with this type of system is called VESDA, but that is a brand name. It stands for Very Early Smoke Detection Apparatus, and so this is the generic term for it. And what happens is that at some point where you don't have to worry about character-defining features, you install a panel, and in this panel is a fan that draws in air into it. So instead of being passive like a spot-type detector that just sits there waiting for the smoke to get to it, for an aspirating type smoke detector system, it's actually sucking the air right into the detector portion, right into here, and it can actively monitor for smoke in the environment. And then what happens up here, and notice this is above the ceiling, and this is tubing. It can be EMT conduit. Sometimes it ends up being, more often than not, I see it being some type of a plastic. CPVC is pretty common as a tubing system for the air sampling system. And this looks really large, but it's a teeny, teeny, tiny little opening, just a hole, a port that would come through the ceiling. So if you're standing down here on the floor, you would look up and would not even be able to see that hole in the ceiling, particularly if you have a lot of a painted ceiling or some other architectural element that that is very important for the character-defining features of the building. And I'm sure that if Kurt was speaking now, he could be a lot more articulate about what you might find on the ceiling in your building. And this over here, we can also use an air sampling type smoke detection system if we have any underfloor spaces, like you would see in computer rooms, or there are some other types of applications where you could have an underfloor space that would require protection. For fire suppression systems, there are three types that I want to talk about that could have application in your historic building. The most common is an automatic sprinkler system that all of you are familiar with, but I'm going to talk about the four different types because of automatic sprinkler systems, because the type that you select for your historic building might be important. It depends upon what you're trying to protect in your space. I'm also going to talk about water mist systems, which is a relatively new technology, the last 20 years or so, and we don't see this a lot yet in historic preservation, but I think over time we will start to see more and more applications of water mist systems for protecting historic structures. And the third type that I'm going to talk about are clean agent systems. Again, this is a generic term. Many of you may have heard of the term halon systems. We no longer use halon because it's an ozone-depleting chemical, and so we have several halon replacement type clean agents that we use. They are essentially gaseous agents that can extinguish a fire without damage to your contents of your building. There are four types of automatic sprinkler systems. Wet pipe, the kind we all think about, the kind you have in the office building maybe that you're sitting in right now. Here's your municipal water purveyor's line right here. You come in, there's a control valve, oftentimes a PIV, and then a fire department connection, and the pipe is wet all the way coming through here, and you come out to your sprinkler system where you have sprinklers that are protecting your space. All the pipe has water in it. And so if you were protecting cultural resources, sprinkler systems don't fail. They rarely do. But should you have someone accidentally knock off a head here, knock off a sprinkler, and if this is wet, you could have water damage in your environment. So possibly for historic preservation, you may want to consider an alternate type of protection. Okay, so this is a slide, I have to tell you, this is a slide on the left that I never thought in a million years I would use in my presentation. But Kurt gave me grief because I had too much text and I had no ability to explain to you what I was talking about on the webinar when you can't see me and you can't see Kurt. So I had to add some fun pictures in here. So this is an example of a dry pipe system. This is actually at an historic stable, the stables at Yosemite, and this is protecting the hay loft inside at the Yosemite stables, Yosemite Valley stables. And I actually took this picture because I'm a horse person and I was walking along in the loft and somebody hung their hay hooks directly from the sprinkler pipe. So I got a little upset when I saw that, so I took the picture. But you'll also see that this hay loft is not heated, and you can also see the slats in the roof where there's exposure to the outside elements. And so if we were to put a wet pipe sprinkler system in this application, we'd clearly have freeze conditions and it would be problematic. And so this is actually the dry pipe valve on the right that is protecting this stable. You'll note, for those of you that have seen fire protection systems, you usually see wet pipe systems out there. And on a dry pipe system, there's a lot of junk that goes along with it. So there's a much bigger space requirement that a dry pipe system would take up. This is a big dry pipe valve here. These lines off to the left are going to a compressor to serve the dry pipe air, because what happens, I'll wait till I get another, I'm going to go to another slide, but what happens is that from here down the pipe is wet, and from here up the pipe is dry. So the room that this whole assembly sits in fact a heated room, because we do have water in this pipe that's running up to this point. So here's a better diagram. We're not going to go through each of these, but quite frankly, I couldn't figure out how to separate the two, so I have it on here. But I like this slide because it depicts what happens in the dry pipe system. This is a valve that's closed, and there's water that's sitting here under the valve with a little bit of priming water on top, and then everything that is in this neutral skin color, peach color, is all air, and there's air under pressure. And if a sprinkler breaks, pops off, you have a fire, any of those scenarios, most likely, of course, a fire incident, then the air that is under pressure will be released, and this valve will pop open, and then you will get water flowing out to your system. In a dry pipe type system, I want you to keep in mind that each sprinkler is what we call closed. So that means if you have a fire, it's highly likely only one sprinkler, or maybe 2 or 3 sprinklers, is going to control that fire. And so each sprinkler has its own individual heat element, and so when it opens up, though only those sprinklers that have fused or opened will allow water to come through it. And so that's typical for a dry pipe system, that we have what we call closed sprinklers. Typically for, let me just go back a minute. Typically for a dry pipe system, we only use them in an area where we have freeze conditions. It's the most common application. So for many historic applications where you have protecting inside of buildings, a dry pipe system is not the most appropriate. However, that stables in Yosemite was a good example. This is what we call a deluge sprinkler system. This is a transformer fire, and what I want you to notice is a few things in this. You will notice as you work your way around the transformer is that we have a lot of different sprinkler nozzles that are all actuating at the same time. So what happens in a deluge system is this scenario. Everything is open. So what happens is that just like this picture, there's water below a valve and there's nothing above it. However, because the sprinklers are open like this, we cannot maintain air under pressure. So for the deluge system valve, you actually need a detection system around it. So there's usually a heat detection system around this that would trip the valve. And then I just wanted to show you the difference between an open sprinkler and a traditional closed sprinkler right here. So a closed sprinkler, the only sprinklers that will actuate are the ones that are physically in the fire area. Again, here's a lovely photograph that has absolutely nothing to do with a pre-action sprinkler system. However, I still thought that it had appropriate relevance to our discussion today. This is actually a scenario where we're doing a test burn in this, and I wanted to, this is kind of good information because what this shows you in this photo is that you actually, how the smoke and hot gases move. So you have your flame, it's moving up the wall just like this. So when we are giving consideration to what we call interior finish materials, this is where you should be concerned about what's on your walls, because this fire is going to move right up this wall. All the smoke and hot gases, hot air rises, is going to rise to the ceiling. It will spread across the entire ceiling, and then it starts to bank down. And the reason why I picked this photo, I do not have a good picture of a pre-action system, but this is in fact an art gallery, and this is the perfect example of where you might want to consider using a pre-action sprinkler system, because it operates just like the deluge system that has open sprinklers, except all of the sprinklers are closed. So only the ones that are physically in that fire area that are hot will activate. So my photo here, this one on the top right, looks just like the dry pipe. It's wet under here, but it's dry above here. But instead of there being air in here, there is a tie-in to detectors. And those detectors send a signal to this panel. So, hey, the smoke detector detects smoke, sends a signal to this panel, tells this valve to open, and you get water flow in your system. But if only this sprinkler opened, you would only get water out of this sprinkler. These two would remain closed, and you would not get any water out of them. That's a pre-action system, very common application for cultural preservation. So let's talk about aesthetics with a sprinkler system. I think that a lot of preservationists have concerns about the aesthetics in a sprinkler system, and I'm going to start here on the bottom right. This is a concealed sprinkler. Many architects choose these sprinklers, but as a fire protection engineer with a great interest in historic preservation, I try to advise my clients against it, because what happens is, in my opinion, well, not in my opinion, what happens is that these caps fall off. And then in my opinion, that is an ugly sight. You have rough edges, and you have this little black hole that's up behind it. And sometimes the ceilings are rather high, difficult to get to, excuse me, and hard to replace that cap. So I have a preference for low-profile sprinklers like this one, which is a recessed sidewall application. This is the same employee housing building in Yosemite where we installed these low-profile sidewall sprinklers. We did it in this application here in the corridor, where you don't even see the pipe here, because we were able to run the pipe inside the sleeping room, and it ran mostly through closets, through the bathroom, and then through the entry hallway, where we created soffits to even conceal the pipe inside the rooms themselves. And so it's very low profile. And there were some applications where we could not conceal the pipe in the corridor, and that was where we constructed these soffits. In this case, it made practical sense because there was no particular character-defining feature in this space, and so building no molding, no special features. So to build this soffit out was not a deterrent for the character-defining features. And what you see, there's a little bit of orange here. That's the system is just being installed, and in fact, they didn't finish painting here. And these are just caps to protect the sprinkler. In this bottom left picture, I like this picture because here's our sprinkler that's going in, and what's happening here is that this is a heat detector right here. This is a fixed temperature heat detector, and because both of these, a heat detector and a sprinkler, actuate on heat, we are now able to remove this heat detector from this bathroom. And so to me, that was a benefit to get rid of this thing that's sticking down out of the middle of the ceiling. And the benefit here is that all this does is detect. This sprinkler not only detects, but it's also going to control fire growth or extinguish a fire. So water mist systems. This is the National Gallery of Art Widener Gallery, and looking at this space, there may be before or maybe after the installation of the water mist system. I can't tell, but the way a water mist system works is that it has nozzles like a sprinkler system, but it is water. It uses a lot less water, and it's water under very high pressure. And so what you see here on the right inset is the pumping skid for the water mist system. So all of this is the pumping skid. So you have a big space requirement for a water mist system, just not in the area with the character-defining features. It's going to be located in some other location. Each water mist system has to be designed separately. We don't have, it's all performance-based, meaning the code, the standard for water mist systems doesn't say you shall put this many nozzles, you shall space them like this, they shall have such and such a density. So it's all performance-based, which is part of what makes the installation and the design costly for a system. They have big space requirements, but they also have very, very little water damage should you have a fire because the droplets are so small and under such high pressure. This is at the National Gallery of Art, and this is Gallery 19, and what you'll see here is a PreWater Mist system, and here are your nozzles after they've been installed. Your character-defining features are very much preserved in this application. For a clean agent system, we generally don't install them that are in rooms where you're going to have public assembly, but a good application might be if you are protecting a space that has art storage. And this is actually a clean agent system that got installed at the Philadelphia Museum of Art, and in a room with no character-defining features, we are showing the canisters for the clean agent system. And there are several other elements here that relate to the system. So here are your canisters that are actually holding your gas, fire alarm control panel, and then this element right here, this is actually your air sampling detection system. So it's the fan that's sucking in air, and these are the tubes that are going out into your space where your detection system is located, and that is protected by your clean agent system. So you have if you have a fire in the room, you have these tubes that are sucking in air, smoke is detected, sends a signal to the panel sends a signal to the clean agent system and says you need to discharge, there's a fire in the room, and it trips the system and actuates. And one of the things I just wanted to touch on, even though we're not talking, the intent is only to talk about sprinkler systems and fire alarm systems for this, is This open staircase is a stairway that we were able to preserve in a building in San Jose called the TUI building. It is a 5-story open stair, and I would be remiss if I didn't talk about the benefits of being able to model how fire growth occurs. We can create a computer model that takes into consideration the geometry of the space and identify fire growth and determine if the space can be maintained in a tenable condition until occupants are safe. Either they evacuate or they're able to defend in place. And for the TUI building, where we were able to demonstrate that with the addition of a sprinkler system throughout and a installation of a smoke detection system for early warning, we were able to maintain that tenable environment for the occupants of the building. And that allowed us to make that presentation to the authority having jurisdiction and allowed this beautiful stairway to remain open. So I wanted to tie in how these pieces work together. And Kurt, you're on.
Okay, thanks a lot, Cheryl. Whoops, let me go back here. One slide. Oops. There we go. We're going to go through 4 case studies, and the first one is the California Theater in downtown San Jose that Cheryl and I worked on together. And this building is important for a couple of reasons. This is actually opening day 1927, and the California Theater is really one of the superb examples of the picture palaces of the early 20th century that's still remaining. As many of you know, most of these in the state and around the country have been torn down, and there were actually about 6 in the San Jose area at one time. And it is also important that it's along First Street in one of the areas that was spared in redevelopment in San Jose, and it's adjacent to several other historic buildings that are still there, the Dorman Building and what is called the St. Clair Building adjacent to it. The important thing about the kind of character-defining elements on the California Theater is that it really was a mid-block theater. This is the original layout. This is what the theater consisted of, which was a stage house, an auditorium, and this long, thin entry foyer. And then it was surrounded by other elements. So it's really only the front 30 feet on First Street that's character defining from the exterior. But within the interior, it's this long entryway, series of foyers that take you into the auditorium. Now, as part of the programming for this building, we actually replaced the stage house. It was not big enough for opera, which was the primary user, and also touring shows, and it also did not have the support space. So all of this construction is new, stage house is new, and all of this construction is new. This entry sequence, which came in from First Street, went through an exterior vestibule, through 2 sets of doors into the entrance foyer, which is really one of the grand spaces of the building, then going into an orchestra and mezzanine foyer that allows you to circulate into the auditorium. The foyer on the left is let me go back. That is the picture taken soon after its opening. Probably this picture, we think is 1929, and it's this grand foyer. And its real masterpiece is the ceiling. Picture on the lower right is the decorative painted ceiling. Now, that looks like wood, but it's actually all plaster mounted up tight to the concrete roof with extensive stenciling, and it was all completely intact when we began the project. Much of the rest of the foyer had changed color, carpet had changed, but there were elements like the steps and everything that were original. But the real challenge here was how to protect the ceiling. And the other thing about this project, the decision was made very early on to do a complete fire suppression system throughout the building for two reasons, obviously for life safety and also for property protection. This is the completed entry lobby. You can see this wonderful decorative ceiling. And we did install a fire suppression system from the sidewalls. This is one of the sprinklers as they go along. And they are able to provide protection, except for they really do not reach high enough up on this decorative ceiling. And there was no place to put them within the decorative ceiling, even if we were willing to penetrate the decorative feature. On the walls, there were cavities behind the walls where we could run the piping, and the plaster, though it had a decorative finish, was fairly plain, and it is something that we actually could replicate in the restoration process. So anyway, we put the sprinklers in, and then in addition to that, we also put in a beam detector system, as Cheryl described previously, and that beam detector system is mounted up tight to the ceiling. This is the transmitter. There's a receiver mounted on this end of this large, the long ceiling, and as you can see, they're really quite unobtrusive. You know it's something new in the building, but it doesn't really change the character of the space. We actually had to offset it to the center because of the restored light fixtures we put in. If we put it right on center, we'd be hitting the chain for the suspension of those fixtures all the way down.
Kurt, can I just interject? I just wanted to give a
Sure.
little clarification. So,
I'm going to go back
sorry.
here.
Yeah, go back.
Let's go back. There we go.
And I'm taking control for just a second.
Sure.
So what Kurt was describing is that what happens is that when we install a sprinkler system, the sprinkler systems, they have to be able to collect heat, because I was showing earlier how all of your smoke and hot gases are going to bank here up at the ceiling. And these sprinklers that we installed are technically, by the code, meaning the fire sprinkler standard, NFPA 13, they're too far down from the ceiling. So there's a potential that by the time the heat banks back down, there could be a little bit of a delayed reaction. And that was why we installed this projected beam detector, was to mitigate the fact that these sprinklers were just a little bit lower from the ceiling than what the code allowed. And so this was actually a design, an alternative method that we ended up negotiating with the authority having jurisdiction, the San Jose Fire Department, in order to retain the character-defining feature of the space, the ceiling here. Okay, thanks, Kurt.
Yeah, and the other thing about that is that even though this is a wonderful gathering space, this foyer is the main exit out of the building from the auditorium. So theoretically, in an event, it takes approximately half the people out. So the protection in this space is very important. When we move into the other spaces in the building, particularly the auditorium, we kind of had two different characteristics. One, over the seating area, there were several reasons in which to do some reconstruction of the ceiling. One is the painting had been lost and was not there. Second is there was seismic work done in this area. And third was we ended up creating these, we call them drop beams, that came down just far enough to hide all of the theatrical lighting. Now, these beams were cast from the original plaster molds, and here they are being installed. But this allowed us to do a couple things. It allowed us to actually put sprinklers in the bottom of those beams. There are also sprinklers up in the ceiling. In the area in front of the proscenium, the first approximately 30 feet or so from the curtain line, here the painting was in very good shape and much more decorative. And even though we were going to, we wanted to install sprinklers, which was part of our program, we ended up working within the vocabulary of that architecture, that decorative painting. So here was the obviously the stencil work. Here was what we would call the plain painting. So obviously we work within those areas to install sprinklers such as this, and still obviously meeting all the criteria. But the important thing to look at here is that this is all very well planned out in the sprinkler bidding drawings. This is the type of thing that you really cannot leave to the design build industry. And again, when we go into the mezzanine foyer, again we had this is a photograph before construction, and we had these decorative painting panels, of which the painting was in fairly good shape. We did do some touch-up in them. The other panels had been painted probably 2 or 3 times over and were less decorative. So we installed the sprinklers, obviously, to miss the more highly character-defining areas, such as these ribs. And an important thing to bring out is kind of when do sprinklers become most effective. These are 2 other theater projects we did. The Portland Theater, which is now the Schnitzer Concert Hall up in Portland, and the Oakland Fox. And both of these are have really quite different adaptive reuses. But one thing that is common to them is the distance from the floor up to the ceiling. And so in both cases, it was analyzed how effective would sprinklers be. Cheryl, I think you might have a comment here.
Yeah, so one of the things that I didn't mention when we were talking about the California Historical Building Code was that when you install fire protection systems, particularly an automatic sprinkler system throughout the building, it gives you a lot of freedom and flexibility in your design and in maintaining the character-defining features and in not having to comply with the prevailing code. So the sprinkler systems that we install go a very long way, and the language in the California Historical Building Code says sprinkler system throughout. But as a fire protection engineer, I like to install systems that are going to be effective. And what happens when your floor area or your area where your potential fuel load would be on the floor gets too far away from the ceiling, so say 50 feet or higher or so, your sprinkler system cannot be effective. What happens is that, one, the sprinkler system may not operate because as the heat rises, it is cooling. And so by the time it gets to your ceiling, it might have cooled to the point where it won't activate your 165-degree sprinklers. But another situation also occurs, and that is if it stays hot enough, if you have a fast-growing big fire, and it reaches your ceiling, and it does activate the sprinklers, all of that plume of fire that's very hot, you are going to have evaporation of your water particles before it can ever get to the ground and actually get to the seat of your fire. So in very tall spaces, the sprinkler system may not be effective. So there may be room for either omission or an alternative method to address that particular space and then still take advantage of some of the benefits that are allowed by the California Historical Building Code. Thanks, Kurt.
Yeah, thanks, Cheryl. Let me grab this here. In the Portland Theater, whoops, let's just go back. In the Portland Theater, the picture you just saw was looking at this proscenium, and again, this is about 80 feet up here, so it's above that 50-foot kind of category at which the activation of sprinklers is not as effective. Um, within this building, though, as you can see, this is a section. We had several different layers of circulation, which were the exiting system, including this was the main foyer. And this was within 50 feet, the vertical height here. So we did install sprinklers. They are located up again within the ceiling pattern. They are located at various places at each of the 3 levels. And we talked about aesthetics earlier in sprinklers. I guess I have kind of a personal bias that sprinklers can be considered included within an historic area. Obviously, this is a new intrusion, this sprinkler up here that we see in this decorative plaster, but it actually can blend and also I think is potentially maybe a little more appropriate than one of the concealed heads. Again, this will be your choice as you work with different vocabularies. The next project that Cheryl and I worked on, which is the St. Mark's Lutheran Church in San Francisco. This is O'Farrell Street, and the St. Mark's was constructed in 1894 when the Western Addition was street after street of old Victorians. Now, we all know what happened during kind of the urban renewal area of many of our cities, that where things did change. But let me just go back. Sorry for that. The interior of the building. This is a picture within the early days of the church, and the character-defining elements are obviously all of the plaster in the historic art glass windows that line the side. Let's move on. Again, in the 1950s, the row houses, 1960s, all the Victorians were taken down along Old O'Farrell. The church was kind of left very bare. New construction happened around it, but the original property lines were maintained, which were very close to the original building, both on either side and at the rear. So one of our challenges as we looked at this project was how to deal with the fire protection, not only within the building, which the congregation accepted as something that they wanted for property protection, partly because there's a lot of wood construction here, but second is because on either side of the buildings there's an exit way that takes you really back out to Old O'Farrell Street. That's the only exit possible. And the property lines are within 5 to 6 feet on either side of both windows on a lower level and the stained glass windows on the sanctuary level. So working with Cheryl, we designed a sprinkler system that we would install within the building and also be able to protect the art glass windows. And in that sense, since the fire would have, in this case, could have come from within the building, protect the exit way on either side of the building. And that kind of vocabulary for keeping the interior and exterior of the building was important both through all the systems, because as you might have expected, this was a unreinforced masonry building. And within these walls, we actually used a center coring system to preserve both the interior and the exterior. You can see on your screen they're kind of small, as hopefully they would be, but these are the sprinklers that line each side of the nave. There are sprinklers up high as well that have a pattern designed to protect not only the interior of the building, but protect the exit way from a fire that could start within the building.
Kurt, can I interject on that one?
Yeah, sure. Shall I go back?
Yeah.
Okay.
So oftentimes when we do property line, oh, sorry, now I have to go back. When we talk about, so what Kurt was describing, these windows are very close to a property line, and in addition to that, the egress path is on the outside of these windows. And oftentimes when we provide sprinkler protection to protect at an opening, and in the fire protection world, an opening means any opening in a wall, so a window is an opening. We oftentimes protect with sprinklers that are directly over the space of the opening. And when we do that, there are rules that we have to follow about no horizontal mullions and how close they need to be, and other special rules for what we call exposure protection. And there were, as you see, we really couldn't, we couldn't compensate for the fact that these historic windows had these mullions. It would have been very detrimental to the character-defining feature to provide them here, and to modify the windows, or even just to provide them here at all would be an impact on this archway around the window. And so we actually used computer modeling to demonstrate that with these sprinklers at the ceiling, we could still accomplish safe egress these sprinklers would actuate, would cool the face of the windows, and occupants would be able to exit on the outside alongside of these windows and reach a public way before they would break. So these sprinklers were actually used to maintain a cooling effect on these windows to protect our egress way. Thanks, Kurt.
Okay, thanks, Cheryl. The other element about this building, and just picking up here, these are these exit ways on either side of the building that go all the way around, is that we did have 3 open stairs that we needed for exiting. 2 were in the front of the building in each of the towers, both the west tower and the east tower, and these were open stairways. And then we had a stairway in the rear of the building. Again, it's in character-defining areas, even though it's out of the sanctuary. And this was our primary second exit from the from the sanctuary that were that allowed the second exit to happen. And then, of course, this exit goes from the main level down to the lower level, and the exiting proceeds around the building. And let's go. And this allowed us to keep these decorative elements in the stair. This stair was actually removed. The concrete reinforcing was put in for the seismic, and actually the stair was reinstalled. And it also allows us to keep this. This is one of the other stairs that's continuous between the upper floor and the lower floor, passing the main floor. Keep that open to the lower floor, allowed us to retain the glazed openings into the sanctuary. So let's go to our next case study. This is the old administration building in Fresno City College. This building was built in 1916. It was originally the home of the first normal school for teacher training in California. It's about 110,000 square feet. Originally, there were 3 other buildings on the campus in this kind of Mediterranean style, originally designed by the state architect. So our challenge here on this building was to work with not only the building itself, maintaining the character-defining elements because it is on the National Register, but also to work with the Department of State Architect, who had jurisdiction. over the project. Here are just a few historic photos of the auditorium, one of the two courtyards, the entry building. And again, this is the 110,000 square feet. All these red lines are unreinforced masonry. The building was really laid out quite well because the central corridors, and these are two-story elements, are all concrete, and there was good exiting. This is the lower floor. These are stairs that are come down from the upper floor. So the exiting path of travel was very good. One of the things as we started working with DSA and the Historic Seismic Safety Board, because of course this was a seismic upgrade building, is that they required this evaluation, design, and criteria report before we started any work. And this allowed us to kind of organize all of the elements that we had to address. And we organized those for both life safety, seismic, and accessibility. For life safety, we would, and for all the elements, we really kind of identified the items such as opening protection, the California Building Code standard for that, what it required, what the condition of the old administration building was, what the section of the California State Historic Building Code that we could use, and how that might provide a design alternative. We had discussions with DSA about that and finally came up with an approach. And we did this for all the items within the building. And this kind of basically formed the supplemental building code for this building as we proceeded through it. Now, relative to the use of the building is primarily for instruction. All the blue spaces are instruction, but also it has administrative spaces. And again, it's organized around these, most of the building, these long corridors. And the other element that became an issue was the fact that we are within 20 feet of the property line of an adjacent building. So that, and here's a section through those two-story buildings, which comprises about 70%, 60% of the spaces. Typically, they organize, as you might think of an education building, around a central corridor, classrooms on either side. But an important factor here is, of course, they all had operable windows, and then along the corridor were a series of operable transoms. These transoms, actually through then venting in the ceiling, provided a path for ventilation, cross-ventilation in the building, provided for light within the corridors. And these were both visual character-defining elements and functional character-defining elements that were important to save. And you can see this, of course, in the historic buildings. This is the buildings basically when we started the project, showing these the transoms into corridors. And so the fire protection system that was used was to protect these transom windows on each side. This is in the corridor. This is close to the end of construction. Some of the finishes have not been quite finished. And then there were also sprinklers, fire suppression over each of the windows within the classroom. In some of those we actually use exposed sprinklers. In this, they are actually a concealed sprinkler. And then what the exterior allowed us, on one side we do have where we're very close to another building, we actually have sprinklers on the inside of the exterior windows and on the eaves. Again, the windows are primary character-defining elements on the building, so they were put at a very high priority. Cheryl? Cheryl?
Yes.
Yeah. I'll move you on to the next case.
Okay, thanks, Kurt. This is the historically known as the Stewart Company building in Pasadena, California. It has housed the Stewart Pharmaceutical Company as its original tenant for many years. It's an Edward Durrell stone building. And we worked on this project with Chattel Architecture, and we got involved to address several fire protection features for the project. Probably the most important, the building was being scheduled for an adaptive reuse. It was being converted to be used as a common area for an adjacent residential project. And so the Stewart Company building is behind this screen. This is the front of the Edward Durrell Stone building. And then there's a walkway that's just behind it, and then the building, the structure itself is actually behind it. And so that was the adaptive reuse for it. There is a second half of this space that's actually way off to the right side, and that half of the building was, there was at some point in history, there was a property line, not an imaginary property line, an actual property line that was drawn right down the middle of the building, and the parcels were sold independently. And so it was the most unique scenario. We have no idea how that ever would have gotten past the city of Pasadena, but it magically happened. And so part of the negotiation that came about with the city of Pasadena as well, it is what it is, and in order to mitigate, we need to allow that property line condition with openings in it. We'll put a sprinkler system throughout the entire building. So this portion that we're looking at now, which was going to be converted to the common space for the residential building, was within our scope. And the other portion of the building, which was not in our scope, was ultimately converted to a performing arts theater. And so our task was to design the sprinkler system for the building, in particular this space, which is the garden court, which is the most character-defining feature of this space. There were many elements that made it character-defining, in particular these planters, these light fixtures, and this ceiling, which you will see better in this slide. It's we have this coffered ceiling. I don't even know if that's the right word. And so these are individual boxes with a little skylight up at the top, and they're sort of a conical or pyramid shaped to get you up into this space. And so there were many, many challenges in terms of the sprinkler system design. One, the first thing we looked at was, well, can we put sprinklers up at the top of these boxes where the skylight is and make it effective? And what happened is that the walls of these boxes actually obstructed the spray pattern completely, so we would have had to have ended up with a sprinkler in every single box in this space, so that wasn't going to work. So then we wanted to explore putting sprinklers somehow on the underside of the ceiling. But then the challenges that we were faced with were the fact that these very, very large planters were creating an obstruction to the spray pattern. So that was causing us a problem, as well as how do we make the aesthetic work in this space so that the sprinklers are not an obtrusion to the character-defining features. And so what we ended up doing is to lay out every single sprinkler in this space, and it is in a non-symmetrical pattern. We laid it out to maximize coverage on the floor, to minimize obstruction by these planters, and to fit in with the aesthetic of the space. And so every sprinkler was laid out. We had a couple, literally 2 spaces, where we just were a few feet off on complete coverage, but that was accepted by the city of Pasadena. And as you can see, we ended up putting sprinklers here, right at the center point of these gussets. And we also did computer modeling to indicate that these sprinklers can be effective by doing a smoke filling model to show smoke that fills up in the space before it banks down to the sprinkler would not cause a significant delay. And so it's hard to tell from this photo exactly what those sprinklers look like. And so I think, let's see. Yeah, so what we did is we created a custom designed escutcheon that fits appropriately within the design of the ceiling. And here in this close-up view, obviously you could see a little bit of paint, but as soon as you're far enough away, you don't see anything from the floor. It just looks like it all fits in beautifully with the character-defining features of the building. And then lastly, Kurt mentioned that it's very difficult in an historic building, in order to maintain the character-defining features of your space, to go completely design build on an automatic sprinkler system. So there's a lot of advantages to laying out the plan in advance, figuring out how you want to go, and approaching it from that angle. These photos are taken at the Badger Pass Day Ski Lodge in a summer. They have a summer application there, and this room right here is one of the most historic rooms in the building. And not only do we have our sprinkler pipe hanging way down here, but we also have things hanging from them. And I'm not really sure who's taking this class, but if any of you know me, you know I'm a little bit on the petite side. And when I walk through this space, I hit my head on this pipe. Also, really poor design in terms of fire sprinkler systems and violating several code items as well. And it's so obvious that there's a problem that they even put this foam insulation around the pipe, because they've had incidents with people banging their head on it. And so, you know, just a word of caution to really, if you're going to be putting in a fire protection system, if you have the opportunity to do more than design build, you might want to give that consideration to maintain the character-defining features of the building. I think we are ready for question and answers.
Yes. Thank you, Cheryl, and thank you, Kurt. We have a question from one of the attendees. We see many wood-sided or wood shingle-sided buildings. How can we make a case to the fire department that these character-defining elements remain? What are some good fireproofing options for these structures?
Well, that's fireproofing. We're not going to fireproof wood, okay? Fireproof means basically that it's not going to burn. And so every condition would have to be evaluated on a case-by-case basis. However, one of the benefits that the California Historical Building Code allows us is this concept of, if you put a sprinkler system in your building throughout, your existing building can maintain its use and operation without any regard for conducting an allowable area calculation. So in other words, theoretically, it's going to allow wood to remain on your building or within your building or as part of your structure, with the addition of an automatic sprinkler system. But I only have part of the story. And so there would be challenges if you were in relation to a property line, because that could create an exposure hazard. Or again, knowing very little, if you are in an urban wildland interface area, wood siding simply may be deemed inappropriate in that application. So there's more information that needs to, there needs to be more information to know how best to deal with that situation. Kurt, did you have anything to add?
Well, I think your first point, or the 2 points you've made, are really important. The first one here, where we have issues with wood-sided buildings or wood frame buildings and what we call Type 5 buildings, which is the area allowable. For example, even that old administration building that was predominantly masonry construction, because of the mixed construction of the wood floors and the wood trusses and everything, it was over area. And by putting in the fire suppression system, it allowed us to keep the building. And again, the other key is its original use. We were not suggesting a new use for the building. It had been an education facility. It was going to be an education facility building. So when you change use, there are oftentimes other obstacles that come in.
Okay, we have another question. Are there any new changes coming in the 2013 California Historical Building Code that are of significance? In other words, are there any really significant changes occurring in the code?
Not that relate to fire and life safety. There have been some recent changes on both accessibility and structure, but not on fire and life safety.
And the other key thing is that the California Building Code sets up a process by which you can pursue alternative designs, and I think that's still really it's a prime component about it. And what you will find is that there's not necessarily a specific example within the State Historic Building Code that you can say, that's mine. What it does is allow you to use a process to state your situation, state your goals, and look for alternatives. And that's really its prime advantage.
That's a good point, Kurt, is that when you're using the California Historical Building Code, it oftentimes will suggest that, say, for example, provide 1 hour construction in a certain location. There are applications in most cases where it says, or a life safety evaluation. And so it's giving you a performance-based opportunity in order to come up with an alternate or another approach. And so Kurt is completely right. That is the biggest advantage to the California Historical Building Code. It's opening up the door to provide a reasonable level of life safety and retain the character-defining features.
Okay, well, thank you. There are no other questions from the attendees, so I'd like to thank all of you for joining us today, and I'd like to thank Cheryl and Kurt for taking their time to make this presentation. You will receive an email with a link to a survey and a link to a PDF copy of this presentation. We would appreciate any feedback on this webinar and recommendations for future topics. If you're not a member of the California Preservation Foundation, we would encourage you to join as an individual, a nonprofit, a government, or a corporate member. Each member receives benefits, including discounts to all of our programs, such as webinars, workshops, the annual conference, and our awards program, not to mention our members-only tours, which we have one coming up at the end of September at Schramsberg in Calistoga. Your attendance at this program helps us fulfill our mission to provide leadership to protect California's historic sites and communities through our education and advocacy programs. Membership information is available on our website. We thank you again for your support and hope you have a good afternoon.